Okay, so again, we're sort of going to leave the grasshopper definition for now. We're going to come back to it, and then we're going to be looking at this area here where we're referencing actual geometry from Rhino, and we're just going to get back into Rhino for now. So the first thing, I always like to model in 3D. I'll change my view. So if I'm in a perspective view and I have properties, I can change the view from a perspective view to parallel. A little bit easier to negotiate the view. This is actually not real geometry, right? I can spend all day trying to pick this. This is from Grasshopper. This is being drawn from Grasshopper. It has not been baked yet. Okay. So don't be confused when you're like, okay, what's happening? It's not locked. You might be doing that for 15 minutes and then realizing it's only in Grasshopper. So if I'm going to model a geometry, in this case, we're trying to do the profile, right? We're going to do some type of an extrusion. In this case, I'm going to make the profile for this extrusion, all right? And we're going to take a step back and then bring it into Grasshopper. So the extrusion can be something that, again, if you don't want to work in the perspective view, we can go to a top view, right? And I'm all fine with that. And we can start using some basic drawing techniques, right? So if we use the line tool and we do 0, 0, holding down the shift key, I might push it to the right. And we know that's a line. I might do an offset. And we'll say this thing is 1/4 of an inch. So we'll do an 1/8 of an inch offset. And we'll offset it. Now we could just have drawn a circle or whatever, but there's many ways to sort of draw this. I do it sometimes just sort of making the box. And let's say it's a little bit wider, so if it's 1/4 inch that way, let's say it's 3/8. So so we'll do 3/16, right? So a little bit of an oval shape, okay? And then we can do extend. So I'm doing this to go over a lot of commands. So now we have the basic sort of bounding box, right? We don't need that line maybe anymore. So what can we start doing with this? We can start talking about arcs. Now when we get into curve geometry and arcs is like, this is like right off of AutoCAD. Like if we were to type arc, it's sometimes too many steps to sort of pick the one we want. So if I want start, end, direction, it's easier sometimes to do the pull down menu. So again, we might use different techniques. Snaps, O-snap, we want to make sure we're on. In this case, we want midpoint, start, end, direction, right? So we can decide like what this means. Now if we want it to be a certain size, this is going to be, obviously, if it was going to be exactly perpendicular. So start and direction might not work that well, right? So we can do another one, arc. So we can do start and point. Start and point. That one seems to work better, right? So how we start to gauge this. We're then going to do maybe a mirror. And then from there we realize, okay, I really want this to be cut at this point here. So this arc is too short, so we might actually have to draw another line here and then offset at a certain distance to figure out really where the arc ends. So let's offset this. In this case, 1/16 of an inch. And let's do 1/32 of an inch. I'm going to delete these because we're trying to draw something that looks like that. So curve, arc, start, end, point. Mirror command, right? Okay, so that's the beginning of maybe the top and bottom. Now we need the offset inside. So let's do offset in this case. Let's do a certain distance, which will be also 1/16 of an inch. Trim commands. Right? Fillet commands. Let's do a radius of 1/32 of an inch. Make sure we pick the right lines. Oh, it doesn't like that. Might be too big. Let's see. Yep. Fillet 1/64 of an inch. I'm using just the space bar to sort of reactivate this. Now I'm just making this up. You guys are, observing what you're modeling and then trying to get close. This is not a forensic sort of modeling exercise. Doesn't mean you don't need to bring out the micron telescope to figure out how many atoms are in this thing. Just be somewhat accurate, okay? We're not going to be fabricating this thing. So then we use the join command. Now, easier than doing each individual lines. Using a window, type in join. Right? And now we have this geometry join. Okay. So we're working with, in this case, we're working with profiles, right? We're always going to be using some type of profile to initiate the 3D geometry. So these simple sort of drawing tools, I'm doing it like using really sort of like trying to use as many tools as possible. You can do this easier ways, right? We can have done an ellipse. Didn't have to like offset each one. We could have just worked in the positive quadrant, made a rectangle, like what we thought the bounding box is. But, a lot of times we're designing as we're thinking. So a lot of times we haven't measured something. We're just sort of like, what does 10 feet offset look like to scale versus 12? We start maybe thinking more in proportions as well. So I draw a lot of times this way. It's a little bit the longer way. But now we have this piece, right? So the first thing we can do is, I'm going to come in here, zoom out. The mistake I made, guys, is I was working in millimeters. So this is going to happen to you. We need to switch this to inches. And if I hit OK, it's going to ask you, do you want to scale it? Yes. So this should be to the right scale now in inches. So always make sure your units are correct. I knew that was a problem because I saw how big it was on the grid, but I didn't want to stop. You can draw everything in millimeters, yeah? Of course, why not? Well, you want to learn feet and inches, don't you? Yeah, I think they did. I think the U.S. is the only country that uses imperial. But there's another country that hasn't claimed to use. I think there's like one other country. I can't remember. But yeah, unfortunately, it's a big over-tooling exercise, right? If all of a sudden, right, all your 4x8 sheets need to be cut. I forgot the meter size, but it's interesting. In Europe, like in Germany at least, the sizes are typically a lot smaller. You can get big sheets, but it's hard to. The materials are usually smaller because, you have to take it upstairs or, it's not easy loading stuff, especially for renovation work. But you can get big sheets of anything you want, but they're actually a little bit bigger than 4x8. Okay, so we have this geometry now. What we're going to do is go to Grasshopper. Mine's down here. And this is, we'll come back to this one. We're going to do something a little bit simpler. And what I'm going to do is reference this geometry into Grasshopper. So what I'm going to use, under parameter, there are all these different geometry sort of containers. In this case, this would be always fall under curve geometry. You can use curve geometry for everything, right? We talked about this. A line's a curve is not a line. So curve will always work with 2D line work. So when I talk about, 2D, that's a curve is what you want to use. So you make this little thing here. So it's curve, or you double click and type in curve. And then you right click and you say set one curve. So basically what this allows us to do we had a system failure. My computer didn't crash. Not sure. The main projector's working, but the software that we use. Let me pause real quick. Resume. We right click on this and we say set one curve. This will allow us to come back into Rhino, select one geometry, and then embed this geometry within Grasshopper. Okay, so this geometry now is part of Grasshopper. So it's within this interface. So you say, why is that important? Well, again, we don't want to model this, right? But we do want to reference, maybe, in this case, an extrusion to our geometry. Okay? Now you'll see why this becomes more critical when we start doing the more complex geometry. For this, it's not as evident. All right, so you ready for this? I'm going to use an extrude command. And for here, it's looking for the profile. So we're going to plug in C into B, base. I don't know why, they use always different things. Well, the next thing is, I do have a line. So there is a direction here, extrusion direction. So let's see what we can use from our geometry. Well, we know we have this vertical line here, right? So the one question is, and this is how you guys might start thinking, so sorry, here's that curve, here's the extrusion command, here's the line. Can I just take that and plug it into D? Oh, look at that. Now, why do you say this is important? Well, if we change the length of the line, the extrusion will change. So a line is a vector, right? It gives us start, length, and direction. So what this is doing, what that line is doing, is giving that extrusion the start, the length, and the direction. So we can start to use the geometry that we have to start to generate a lot of 3D. Now, we're not always going to be doing this, right? Because sometimes our geometry is fairly complex. Especially when you look at the umbrella, there's a hinging. It looks like we might have had a power surge, because I think the server just went down. I know the server in the library just went down. Interesting. Too many computers on. Okay, so this length is this is like the easiest thing of sort of associating a geometry into Rhino. Now, let me just change something, guys. Sorry. I customized this at one point. That's when it's selected. Okay, so you can see it a little better. So this right here, guys, this is how you preview the geometry. This is when it's normal, and you can make it transparent. And this is when it's selected. So it was just black. I don't know why I had done that. At some point I must have. Hold on, it's trying to connect back to the server. Oh, everything went down. Ooh. Oh, Wi-Fi is down. Yeah, I wonder what we had. Looks like it's all coming back up. Someone must have switched the breaker. Didn't realize it turns everything off. Alright, so here we are. We can see that geometry. Now again, we can adjust that by length. Well, I want to do something real quick to show sort of the sliding of the two, one inside the other, right? So we typically with umbrella, it might even be 3 sections. Typically it's at least 2 sections, unless you have the full length umbrella. So say I want to start thinking about this situation, right? Where you have one sliding into another, right? Like how does this geometry start to work for the umbrella? So this is within that umbrella piece. So what I can do is start to look at my lines here, right? So I know when I rotate, I want to do this on the rotation. So I'm adding a little bit more complexity to this. I mean, number one, based on the size of my umbrella, probably this is too small. So if I scale this up, it's automatically going to update in Grasshopper. So whatever I do to this, in Rhino, it's gonna translate. So they're linked. Okay, this is like a linked geometry right now. Well, the other thing I know is I want to have an offset. So I'm going to take this geometry and do an offset. Let's just do a 1/16 of an inch. See how, and let's go. Let's do that again. Let's do a 32nd. So that's sort of my outside, that's my inside, okay? And then I want to sort of actuate this, that it's moving. Yes? It could be a video card issue. So you have it off right now. So right click on extrude and say extrude. Yeah. So you have it on. So you have this selected. It's only draw like it. Don't draw any. Okay, let's get through this part, and then I'll see what other issues you guys are having. All right, so to create this effect of sliding, we need a short piece and a long piece, right? And they somehow have to engage each other, so they have to slip past each other. So I'm going to just go here and turn this off real quick. So so I don't see it. I'm still going to use this line. So this line is still going to be critical. But I might evaluate like two different lengths. So this is what we were doing before, like the midpoint, and then sort of understanding where we grab a point. So we basically want to draw two lines. We want to draw a line that represents this piece, and then a line that represents this piece, right? So they overlap. Now to do that, there's a couple ways we can do that. We can find points that are located on here like we did before, which will be the easiest. So we'll use this similar, So we can use this similar command here, point on curve. So under curve, we have this point on curve. And I'm going to make this pretty simple where we go 2/3. So I'm going to plug this line into here. So there's one. Yeah, 3/4 too. Let's do 2/3. And then we want to do another one of these. Copy, paste. This one I'm going to set to 1/3. And maybe that's too much of an overlap. Let's set that one to midpoint. So this will be the overlap. Okay? Does that make sense? So what we're going to do now is draw two new lines. So we have this point here, and then we have this line. I'm going to use endpoints. Endpoints finds the endpoints of this line. So I have the start and the end. So then I can use the line command. And we know we want to go from start to 2/3. This is that line. A little hard to see here, but this line is producing a line that goes from there to there. And then we're going to make another line. And that line is going to go also from endpoint to the 50. So that's going from there to there. So the overlap is here. So this creates the beginning of the overlap, right? Then we can look at our extrude, and rather for the first one, we're going to plug this line in there, and we'll show this. So there's that extrusion to there. That's the longer piece. And then we're going to reference this outside geometry. So I'll grab another curve container. Set one curve. Pick that geometry. Grab another extrude. Plug that into B for the base geometry, and then this line is here. Now, you can see something going wrong there. Like where this is actually appearing. And this is being driven by where the geometry is, okay? So that geometry is located down there at the base. And it's extruding it down because the vector, this geometry, is moving in the negative direction. Which is fine. We're going to reorientate this anyways. And then use a move command. So initially, if we look at this using vectors, so this is another way to look at this. What I'm going to do is use a, under vector, we can display the vector. So this is the start point, like where we want the anchor point to be, and then this is the actual vector. And it'll show us like what direction it's going into. So here's our line. That's our vector. Our anchor point is there. A little hard to see this. Let me turn these off. But if I select that, you see this is a line. This is representing the vector from there to there. So we know that line is moving down. Okay? Again, everything is based off of start and then length and direction. Everything we do pretty much in the software is always going to somehow be dependent on that. All our vector geometry is, right? We start losing that once we start getting to NURB curves, but we still probably are working with some type of referencing geometry that is based off of vectors. All right? So that's why this piece is moving down. So how can we get that piece moved back up? How can we get this up there? What would you do in Rhino? Yeah, sorry. What would we do? If I want to move a geometry up in Rhino, what would I use? Help me, guys. Move command, right? I can move the geometry where it should be, right? So if I just take that geometry in Rhino and move it up there, that solves it really fast, right? Now, is that associated to that line anymore then? No, right? So if I move it in Rhino, it's fixing that. I'm assuming it's 30 inches, right? Because we have 30 inches for our SDL. So we would move it up 30 inches. But if we change the length of that for some known reason, that would stay up at 30 inches, right? So we want to associate it to this line, more importantly to the endpoint, right? So if I move command, is there another command we can use? What else do we use in AutoCAD to fix geometry in 2D? Something's there, we want it to be there. What tool do we? Well, I think I heard it. Starts with an A. Align, right? Did someone say align or align tool, right? Do you guys use the align tool? No. Well, in Rhino it's orientate. So we can reorientate the geometry to another position. Now this is going to be a simple orientating of, Z0, Z30. Right? Can we do a move tool in Grasshopper? Sure. I'm going to show you orientate because that's going to be critical how we start putting more complex geometry to other positions. Okay? So we're going to use an orient. Orient command.
What's the difference?
Just the control. So a move command, it can only move in a vector direction. Orient, we can basically flip it, reorientate, rotate it, reorientate the vector direction, so it has more capabilities. Does that make sense, guys? A move command can move something. If this thing is laying like this, I can move it, but it's still going to lay like that. Like the piece won't be able to be flipped. With orient, we can move it there, but then also lay it, flip it, based off of a plane. So orient is going to be a much more powerful manipulation tool, all right? So transformation tool. So just follow me on this because this is the easy part, because once we start making really more complex geometries and orienting, it gets a little more trickier. Okay? So far so good? How many people are completely lost? Oh, that's good. Not or just shy. How many people are shy? That's a no one raised their hand because you're shy. Of course you're not. Okay, so let's look at orient. So we have orient. Great little thing. Not much to it. Geometry, where do you want to orient? And then AB. These are reference planes. So it's really basic. So rather than dealing with vectors, we're dealing with planes. So I have my cup here, and I want to orientate it like so. It gets reorientated, right? Plane here, plane here. Does that make sense? Here's my plane. I can put it on here. All right, so we're dealing with planes. A lot easier to deal with. And planes are really easy to deal with because we can make custom planes fairly easily in Grasshopper. In this case, it's really simple. I want to go from 0, 0 to another xy, right? So what type of plane do I need to create? Just gave you the answer. XY. All right? So we're going to go to vector, and we're going to go to plane, and we're going to pick an XY plane. By default, it's located at the world position here. Well, we want it to be located at the endpoint of our SDL, right? Which is up here. So far, so good? So I'm going to plug, so here it is. I'm going to plug endpoint, which is here, into O. So all of a sudden now, that plane is positioned up there. My curve geometry, want to make sure we grab the right one. Is that one. That's where we're going to reorientate, G. And we want to move it to there. Well, it's going to be up there. There it is. All right. Because this is always defaulted to 0, 0 world. The initial plane. Now, if our object was not at 0, 0, we would have to tell, what can we use there? What did I show you earlier to find the centroid of it? Area. That would work as a plane. So I can take this geometry, do an area of it real fast, and then plug the C into A. Nothing changed. But this C, this point, is working as a plane as well. Okay? And you can see it's 0, 0, 0. So if our geometry is drawn somewhere else, like if I take this geometry now, and I'm a sloppy person and I drew it somewhere else, it's still being repositioned here. Forget about the extrude, we're going to fix this. So it doesn't have to sit at the 0, 0 position. We can draw anywhere. A lot of times I draw these profiles like, you know, I'm making all the parts or all these profiles, just lay them out. Because sometimes we draw them all at 0, 0. It's a lot of geometry in one spot. And then you got to deal with layers. So you turn things on and off. So a lot of times I just fan them out. And then I do the center, right? I get the centroid of it based off of the area. And then I reorientate it that way. It's not a problem. How you want to work, you can work. Now this G is the new geometry. I don't want to extrude it from here. I want to extrude it from here. So I plug in G in for B. That goes away, and now it extrudes in the right position. Turn on this extrude. We have the two geometries embedded inside each other. It's going to get more complicated, guys, in a minute.
Wait a sec, so you took that extreme up curve?
This orient?
Wait, yeah. The curve, that curve is attached to extreme.
Hold on, let me make this bigger.
Right, okay. So that curve is now,
This curve here that we reorientated is the new profile.
okay.
So we don't go straight from here into here. We move it and then put it into here. Okay. How many people did I lose now? Nobody yet. All right. Be no reason why you can't do this by next week. I mean, it's not difficult stuff. I think you have to train you have to train your brain to understand what's happening here. But, if I told you, how does the metro come in, or where does the Amtrak go across the U.S. for line so and so, right? You can figure out the stops and it went there. And, it's not rocket science. It's really a visual interface, and it's cueing in to what's being manipulated, right? Our reference curve, we're finding the centroid of it, an area. Centroid. Hey, you don't know what centroid means? Look it up. Could be the case. But you guys did structures probably, or in the process doing structures. XY plane. Orient is looking for two planes. The centroid is acting as the initial. The XY plane, which is positioned at an endpoint, is telling where it needs to go. Geometry orientates it, then we can extrude it. Yes?
Why do you create two lines instead of using the same one for the vector?
For the vector length, because I'm using those lines to define the extrude.
But why do they extrude two different lines?
Because maybe they're not exactly the same. I don't know. I'm just assuming they're not. One is longer and one is shorter. Because maybe one goes into the handle. Does that make sense?
I thought that was the offset geometry and those different.
Yeah, no, yeah, but then this is a shaft. So this is where the handle goes. So they might not be the same length. I'm generalizing the geometry of the umbrella. All right, we're going to do one last tricky thing, and then we'll take a short break, okay? Now I want to animate this. Okay? So I want this thing to shrink as we rotate the umbrella open. I don't want to make another number slider. I want to do that with the rotation. So as I rotate this thing's going to move. So we're going to be using a remapping tool. Okay? This makes sense? A little bit? Let's take a close look why this is going to be important. So this is where I want to start turning on. So that's the arm. Now typically, this arm, whatever, it can slide past this, but I'm not too worried about the orientation of that arm to where that is. I'm more interested in that I do this, and then this thing moves. But what's happening here? What's staying static? The top, right? So it's sort of doing the opposite, which is fine. So we need the shaft to actually move up. Or out as we move up. So as this thing moves down, and it's probably moving, it's not going to move much, as you can see. So if we can assume it's going to move about, maybe it collapses to there. So we're going to start figuring out what the constraints are of the degree rotation. So I'm going to edit this. I'm going to set this to 6. And then we'll assume, you know, all the way open is, let's say 50. So that's our range. So as this thing is sort of coming close, this is sort of moving in, right? Up a little bit. It's not much. I mean, the proportions I have are probably not exactly, but I just want to show you the next thing is remapping, because remapping is going to be critical, because in the end we want one sort of slider to do all the work, right? I want to move one thing and then everything associates to this one piece. So now I'm taking numeric values and then applying them across the entire project, right? So how do we do this? All right, so we know we need to move this piece up. Okay, so I'm going to use a basic move command. This is this piece here. We know we want to move him up a certain amount. So we want to move it in the Z. So I'm going to use a move command. Plug that in. And then I'm going to use unit Z, Z direction. Double click MOV. That's move. Oh, you just type in Z. You'll get unit Z. So that's producing a Z. I know it looks like an N. It's really a Z. Turn your head. All the text is running bottom up. Okay? And now I want to figure out how much I want to move this thing. So I'm going to put a number slider in there just to test. Let's change this value. You'll have the aha moment. Don't worry, guys. We're going to go over this. So this thing's moving up. Now, it's hard to see, but there's two geometries right here. There's the original extrusion and now the move. We want to turn off the original geometry. So you guys understand, in Grasshopper, when we do a move command, this is reproducing the geometry. The original extrude is still there. So it's like everything that we make is there, and if we manipulate or transform it, it duplicates each time, right? So we have to get used to turning things on and off. At the end, we're ultimately going to pick the geometry we want and sort of compile it into one piece. But you guys have to understand that just because I make a move, the other one doesn't turn off automatically. I have to manually turn it off. All right, so say we want to move this up. Let's do 5 inches. All right? It's not collapsing much. So I want this action of 0 or 6 to 50, all right, to get remapped to reference 0 to 5. This is like computer programming 101. Remapping tools are really important. So we have something that's doing 6 to 50, right? And we want that to represent 0 to 5. So somehow this has to translate, you know, what we have here for, you know, 44, you know, to all the way, you know, if we include 0, we're at 6, right? So we don't have to do this manually. We can come up with a formula to do this, but there is a remapping tool. Now the other issue we want to verify, this is going at 6, we want it to be at 5. And at 50, we want it to be at 0. Does that make sense? We actually want it to go in reverse. Well, we'll reverse it, but we'll do it later. Okay? So when this thing is at 6, we want to make sure we're at 5. And when we're at 50, we're at 0, and then we want all the in-betweens. Okay? So let's look at the remapping tool. So if we type in remap, so here's remap numbers. So the value to remap, and then it's one locally defined value, and then the target domain, like what is our target? So let's look at this, because I know they changed it recently. Let's make sure it's working the way we think. So these are eventually the remap numbers. So we basically want the value to remap. Well, we want to remap the top values, right? So we have a domain from 6 to 50, okay? So this is where, if we right-click on this, by default, I don't think there's anything in here. What we're going to do is go to Domain, and we're going to do Construct Domain. So we're going to get a DOM, Domain, Construct Domain. This is going to construct a range from something to something. And then it's going to give us 0 to something. Okay, so we want this to be 6, and we want this to be 50, right? Does that make sense? Now, the tricky part eventually, so these are the values. This is what we're plugging in for the values. So we want to make sure that's our number slider. At least let's hope so. Okay. So based on where we're at, our output is going to change. Now, by default, it's going to remap it. We're getting the same values out. Okay. So we're going to set, and this is going to be our source domain. So this needs to be 0 to 50. And then our target is going to be 5 to 0. Okay? So we're going to make these domains. Now, we're sort of fixing what this is. So I'm going to put number sliders in here. Let's make this 50. It's probably a different version, so don't worry. We'll just need the R. We'll just need the remap. The C is with clip numbers, so if we wanted to take away numbers, so don't worry about it. So we're going to set this to 6. And we're going to set this to 50. And our domain is 6 to 50. And we're going to plug that in as our source.
So you can't extract the maximum and minimum value of the number slider?
We can. Well, we can. There's ways of doing it. A little bit complex. We can use, for our number slider, we can extract the domain from it and then decompose it again. But let's not do it right now, because we would have to write a little script to do it, and I don't want to get into that. We're eventually going to start doing some scripting, some really basic, but not in this case. Okay. So yeah, we could get information, because you see it gives our lower limit and our upper limit. We can pull this out.
You have a VB?
Yeah, we'll have to do a VB script. They might have made a component now that does it, but I don't think so. Because last time I've done it with VB script. So, hey. Yeah, of course. Yeah. Are you going to be around for a little bit?
Yes.
I want to talk to you. Okay. Oh, again. Something's tripping.
Can I use this one?
Yeah, as soon as it kicks back on, something's tripping our, and I don't think it's anything. Okay, everybody, let's figure out this. We were on this remapping. All right, so we have the domain here. I'm gonna switch this domain. This domain was gonna go from 5 to 0, yeah? Oops. So let's see if this is going to work. We put that in as our target. It's working. So if I go to 50, 50 is 0, yeah? If I go to 6, 6 is 5. If I go somewhere in between, it's, somewhere in between, 3. So this domain from 6 to 50, this is our source. From 5 to 0, we did a negative, right? We flipped it. Target creates our, in the end, the sort of output, which is remapped to this 6 to 50 range. So this is going to be a critical tool, this remapping tool, because we'll be using different, different ranges to create different outcomes, right? So if we understand the whole project and it has a set of ranges, right? One is 10 to 12, one is 1,000 to 2,000. We can ultimately figure out where the start and stop is of those and remap it to 1. So they all perform the same, sort of the same start to end, per se, right? So we're controlling the start to end. So what we do then, for that move tool, we're removing this, and we're moving this here in the Z. I'm going to plug in, let me try to organize this a little bit so you guys. So rather than using this number slider, we're going to use this output R for our Z. So now when I slide the number slider, it both slides, and the range is what I expect. Does that make sense? So I'm controlling everything with one command. Now again, my proportions, I'm just guessing the proportions. I'm not trying to use a real umbrella, because last time I did that, everybody bought the same umbrella I had. I had like the cheap Walgreens umbrella. So it's nice. I'm already seeing people have different umbrellas. Each umbrella is like its own animal, so everybody puts a spin on it, so they're all a little bit different. And if you're modeling something totally different, then it's even more so. Okay? This makes sense, guys? Remapping, very critical. All right, I'm going to stop the video here, and then we'll talk about more modeling.